Hello everyone, welcome to this simple physics-based Unity tutorial. We'll be using WSD or the arrow keys to move around the scene, and there'll also be jumping. So for the scene we need the ground, which is just a plane. An obstacle, you don't need this, but just to test collisions it's useful, and to jump on. And then the player can be anything you want. I just picked a cube, but it can also be something like a capsule. On the player we need a rigid body, and turn off and freeze all the rotations, and also make sure it has a collider. And then we need a script. I'll create a folder for scripts and create a C# script and call it player movement. The first thing we need in player movement is a private rigid body variable called RB. In the start function we also have RB equal to get component rigid body. This is getting the player's rigid body component. Now we need to create the movement direction for the player. How the player is going to move is there's going to be a direction, and it's going to add force in that direction. So private vector3 movement there. In the update function we'll set movement there to new vector3 input.getAxis, and I'm going to use getAxis raw because I don't want Unity to apply its own smoothing, but you can use getAxis. So input.getAxis raw horizontal. For y it's going to be 0 because we're not moving up and down with the arrow keys or anything. For z it's going to be input.getAxis raw vertical. Horizontal is left to right movement, vertical is forward and backwards movement. Now we need to apply those forces. So in the fixed update function, we're doing this because the fixed update is run in every physics step. RB.AddForce movement there is going to be the force or the direction, and then we're going to multiply that by a speed variable, public float movement force. Now we have to attach that to the player. I'm going to set the movement force to 50 and play. So if we press on play, and then you can see one problem immediately. It's very slidey. And now you may not realize this other problem, but if you're going diagonally, your speed is doubled because there's twice the forces being applied. So to fix that, first of all, to fix the diagonal movement, we're going to say movement there.normalized. That's just going to normalize the vector to get a magnitude of 1. And now to add counter movement, so the player doesn't slide around, we need to add another vector called private vector3 counter movement. And in the update function I'm going to set counter movement equal to new vector3, and this is going to be negative rb.velocity.x for the x-axis, and we're going to multiply this by a variable called counter movement force. And for the y's there's no movement there, of course, so 0. And for the z, negative rb.velocity.z multiplied by counter movement force. And now we have to add counter movement force to this calculation over here. Or sorry, not counter movement force, counter movement. And see. So in the player we have to set counter movement force to, I'll set it to 5, and let's see if that works. So yes, now it's more snappy, there's no sliding around. If there's a little, it's fine. It feels good. And also, if you don't want any at all, you can just turn up the counter movement. The reason I like this AddForce and counter movement is because if you're on ice, for example, you can control how much he slides. So yeah, that's useful. Also, the diagonal movement, it feels a lot more controlled now. It's not like automatically going twice the speed. Yeah. Okay, so now I want to add jumping. So for that, we have to know if we're on the ground. So I'm going to create a private bool here. And we also need one more thing. It's going to be called public transform. It's going to be called ground check origin, or just ground check. And we can say on ground is equal to physics.check sphere. And this is just going to make a sphere and where it checks at the bottom of the player's legs to see if it's on the ground. The position is going to be ground check dot position, and then the radius is going to be something like 0.2f. Don't make this too big, because then if the player is not on the ground but he's close to the ground that the radius allows, then he'll be able to move. And don't make this too small, because it might not sense that he's on the ground at all. Then finally we need a layer mask. So for this we're going to say up here, actually I'm going to say look layer mask ground layer. And now we're going to make the jump function. So if input dot get key down, key code dot space, and then if on ground, ib dot AddForce transform dot up times jump force. We need to add that variable. And on the player, for the jump force, I'm just going to set it to something like 300. That's what I had in my test. Ground check, let's create that. Create entity ground check. I'm going to set this to negative 0.5 because that's the bottom of my character, since it's scaled to 1. And for the, I need to attach that. For the ground layer, we need to create a layer called ground. Press add layer ground and attach it to the ground, of course. And also, if you jump on the obstacle, you should still be able to move, so attach it to that as well. And press ground here. Now let's test this. And you can see we can jump, but we can't double jump because while we're in the air, we're not on the ground. And you can also jump onto this object, hopefully. Yes, very nice. And we can also jump on this as well. And we can jump in the air again. So now what I want to do is, since you can move in the air, that's not very realistic. So if you're making a realistic game, you might need that variable. And this is just a very easy thing to add. Just public bool can move in air. And down here, if you can't move in the air, so if not can move in air, and you're not on ground, then return. So it won't add force if those two are true. Let's see. So on the player, I'm going to set can move in air to false right now. So if we jump, we can't we can't move in the air. We can't do anything about that. Now let's set that to true, and now if we are jumping, we can still move in the air. And that's it for this tutorial. This is very simple, so if you have to make first person movement or something, then you can add a first person camera and make it move in the direction the first person camera is looking. And also you can make this into like a platform or something. If you're using 2D, you can make it fit for 2D. You can do a lot of things with this, or you can make it realistic or something, anything like that, or you can make a third person controller. Anyways, if you have any questions, I'll leave them in the comment section, and goodbye.